I was in your class and I didn't like switch schedules or anything, but it took me out.
No, Anna, you're in it. Like, I still see you, but
No,
sometimes Desmos gets
I
weird.
just joined, but now I don't see your assignments for some reason.
Click go to student homepage. Here, I'll come show you. Might also be the different computer. Oh, you're trying to log in as teacher.
What?
You're on teacher.desmos. Yeah.
Oh.
You gotta notice what website you're going to.
My bad.
So, did you Google it and then just follow a Google path?
Yeah.
Yeah, that's what happened.
I just put
So,
Desmos
type in
and
my
I
code
hit
there.
enter, and then it like.
Type in my code there. I'm going to double check if you somehow joined my class and need kicked out as a teacher.
Oh.
Yeah, it might think that somehow like you're a co-teacher of mine.
That'd be funny.
All right, I don't know what it thought, but I don't see you in there as a teacher, so we're okay.
Good.
It's fine.
I know what time you get the folder invite.
Do you? Interesting.
Okay.
Well, we'll go back to that problem here in a little bit. So on your pool border problem, you are trying to figure out how many border tiles we would need for a 5x5 pool, 10x10 pool, 13x13, a 16x16. All of these different pools, because everybody has to keep making bigger pools. What do you think, Katie? So 3x3, so we use like an X to mean like by, like dimensionally. So the pool is 3x3, but the border ends up right there. The blue part is the pool. The pink part are the border pieces. So it's like where you could walk, right? And the lifeguard would yell at you, no running. That part of the pool. I don't know. Dude, what you had was great. Why'd you delete what you had typed out? I mean, your answer's still right, but I love what you had typed out. Once you guys get done with one of the slides, move on to the next one. Find out who my students are available. It's up to you. What color is it? Does it say your name on it? On the inside? Alright, when we find it, we're going to make sure it says your name on the outside. Because your name being on the inside is going to make things a bit trickier. Alex, you need to go back to slide 9 and try again. So what's interesting is the different stuff you guys are saying. So 16 because perimeter of the 3x3 is 12, and including the corner makes 16. 3x3, there should be 5 at the top, 5 at the bottom, 3 in the middle on both sides. So it's 4, wait. I think they need to decide whether it's 14 or 16. And I'll unpause in a second, right, after we appreciate some of these. And this is anonymized, so we can't tell who we are, especially because I'm recording. So 16 because each side then add an extra 4. 13 and no real reason given. So guys, this is like when you answer on a test and it's just wrong. All I can do is mark it wrong, right? I cannot figure out what your thinking was. 12 plus 4, again, like the other method. Ooh. I need 16 tiles to surround the pool. I know this because I took the length of 3, added 2 to each side. I did this because I know there needs to be 5 tiles to fully cover the pool side. Then I multiplied 5 by 5 to get 25 and took away the water 9. I got 16. That's like exemplary level type answer right there.
Okay, copy paste.
All right, so go ahead and keep going.
Yeah, I'm not
Go ahead and keep going. How can we use this to eventually find any sized pool?
Oh, I like the years of the week. I'm still on this one because it's further along.
You're good. Keep going. Just keep going. I might, on days when I'm going to do Desmos, try to sneak around your other classes and be like, have your computer open when you come to me, but I know you're not supposed to do that.
There's people who walk around the hall with like their computers open.
Oh, I
and
know.
they draw
It's a
their
danger.
computers,
Yep.
And it scares me.
Yep.
And it's not even my computer.
So let's do some random cards. I know you're unpaused, but if I call on you, please, chat with me for a moment so I don't feel so lonely. Now, Mikey, I know it took you a minute, so I'll call on you here in a bit. I'll shuffle you back. Missy, how did you... So I think we've all kind of agreed that we're going to end up with 16. I think maybe. That's what most of you guys said. How did you get to your answer for the first one?
Oh, okay. So basically, so that's 5 by 5. So what I did was I took the sides, right? So
Or sorry, yeah, not the first one. My bad. The first was 3 by. So this is like the 5 by 5 pool. So sorry. Go ahead, Missy.
so I just did. So I took the 5, and so I know that if it wasn't like a perimeter, then it would just be like so. So since it's 5 by 5, I did 5 times 4, and then I just added the corners to it.
So Missy's saying
Wait.
these are 5. So Missy did 5 times 4,
Plus 4.
and then the extra corners. Hey, don't make me go pause that. Look up here real quick. Does it make sense, especially if you did it differently, that Missy said, I've got 5, 5, 5, and 5, and then the corners, which there are 4. Does that make sense? And this one then I think will come out to be 24. Can somebody tell me a different way that you thought through this? Eli?
I took the initial, middle, which is 5 times 5.
Okay.
And then I added the 2 corners, so then it would be 5 plus 2, times 5 plus 2, and then minus 5 times 5.
You were that really long response, weren't you?
Yeah.
So what Eli did was he did 5 plus 2 times the other 5 plus 2 to make all of this area. And then so 5 plus 2, really what you did, bud, is you squared it, because times itself, and then you took away the 5 squared. Impressively overly complicated. And I don't mean that in a bad way. This is overly complicated, but that is not an insult. It's kind of a compliment here. Complicated. Okay. That works. There's other ways. Nathaniel?
This is just it's a relevant comment, but couldn't you do X to find any amount?
You're further down my screen, bud. We're on this one right now. So you're probably right. I'm betting you're going the right direction, but hang on to it. Right, hang on to your horses, as people say. Olivia?
What I did was I just added took the top layer of the pool and then I added 2 for the corners,
Oh, you added 2. Okay.
and then I times that by 2, and then I just took the side dimensions and added them together.
So 5 plus 2 times 2 plus 2 5s, right?
Yeah.
Okay, yeah, that'll work too. So I know which response you were because I can tell by what people typed up. So here's really where the question goes and what Nathaniel's trying to take us to. If your pool length is any, guys, in my head, maybe it's just me always trying to make dad jokes, but any
Yes.
length.
Yes,
Like-
let's go.
Yes, I see.
So if it's any length, this is what we're trying to get to. I don't want your answers yet because I'm going to check on how we're doing over here. I know, dang it. All I want to do is do math and he won't let me. Guys, remember to keep going. So, like, oh, never mind. You're just back at the first slide looking at it. You already did more than those. So we get to this x by x or n by n or whatever.
Stop flexing. This hurts.
Now wait. Well, I got an idea that I don't know if any of you did on the 5 by 5.
Wait, can I guess?
Sure.
Is it you take the number, add 2 to it, and then multiply by 4?
No, because that would be too many.
No, that's how, because I did
We
that.
did the number plus 2. We multiplied by 2 and then added that. Like, if you do 7 times 4, that's too many.
How did I get the right answer?
I don't
I'm
know.
so confused.
Multiple mistakes,
Many.
Mikey.
You asked me for a different way to do this, right?
Yeah.
I have an idea. So, you take like all sides 5, and then you add it by 2, then you multiply it by 2 to get 2 of the sides, and then you add 5 times 2 to get the other 2 sides.
You mean this? That's written in purple.
Yeah.
You mean the one that we already did?
Oh.
So you're good. It's right. What you said is right, but it's not different because we
just
did that.
realized that.
I think you were spaced out somewhere. Now, guys, this, and like, all the love to Eli, but this is overly complicated. What if instead of doing 5 plus 2, I do 5 just plus 1? Could I then do another 5 plus 1, and another 5 plus 1, and another 5 plus 1?
Yeah, 6 times 4.
So that'd be 5 plus 1 times 4. That feels way nicer than what we wrote. Not right versus wrong, but nicer. Like, you know, like Twix versus Reese's, or not, like, I'll take any candy bar, but like, I've got my preference, right? I mean, I'm getting in the Halloween spirit here. Reese's is way better.
You're gonna use the Halloween.
What?
There you
Yeah.
go. This is mathematic. There's a proof, Margot.
I noticed that the last one that you just did is really similar to the first one.
Wait, what do you mean? Do tell.
Because, so you're adding 4, but if you, like, distribute it, like, then you have plus 4 and times 4.
So wait, if I distribute this, this is really 5 times 4 and 1 times 4, which is just it's the wait. Oh wait, you mean like all of these are actually the same?
Yeah.
Oh.
That's so cool. I never knew that.
Oh, that's interesting.
Oh.
So then for n, I want to see what you type in the computer. Put your hands down unless you've already typed it.
I haven't thought of it yet.
I already
I
did.
Well.
nothing has come to my tiny brain yet. Already typed it.
Take your method and substitute.
I think you made an unintentional dad joke earlier. You said that you were getting in the Halloween spirit.
No, I don't know if dad jokes can be unintentional because like it's just part of your persona. It's like
I don't get it.
it's like your brain is.
Halloween spirit? Like ghosts? Spirits?
What is happening? You only get that because you play Halloween.
Hey Mikey, I'm pretty sure you've got more Desmos to do.
I have one question.
But slide 9 is wrong.
Like Halloween.
No, but slide 9 is wrong. Yeah. So quit turning around and poking at jokes. Guys, I'm not joking. I'm in school right now. Like, I'm getting my graduate degree. And one of the research papers I was just reading about CPM is CPM stating we are not I do, we do, you do. Which, like, a lot of not broken, I shouldn't say that. But, like, a lot of math classrooms will be the teacher does it, then we all do it, and then you do it. And what's way better for learning is, hey, here's this task. Go for it. And as long as you feel safe to make mistakes and, like, that getting the right answer doesn't matter that much and you're just here to figure stuff out, like, that's the better way to learn.
So it's like a pre-test of the assignments, kind of.
I don't know. It's just learn. It's just play with the numbers until it makes sense. Alex?
It's not.
Every
I'm saying,
single
like,
one
say that this is
on
and
nine,
say that like
and
this
they're
is also
all
like this is the method.
We'll talk about it in a sec. Well, if we have time, we'll talk about it. All right, so on the any size pool, I see n times 4 plus 4, 4 times n plus 4. Ooh, n plus 2 times n plus 2. Oh, that's Eli. Sorry, we know the method that you got stuck on. Ooh, n plus n plus n plus n plus 4. Still 4n plus 4. Oh, now we're using capital N's. We're getting angry.
We're getting angry.
Oh.
No, John.
So,
There's only one dad joke in the room.
so guys,
That's him.
whether... Hold on.
You guys
Hey, hey, don't make me pause it. Whether you take the default that most of us are taking of saying, oh, we're going to have 4 times whatever n is because this for sure has pavers or tiles, whatever you call it, and then the corners are going to add 4, that's right. So is if you just manually add up all of the n's and then add the extra 4. It's also the same as if you do the n plus 1 times 4. It's also the same as if you do Eli's n plus 2 times n plus 2 minus n times itself. It's all the same. A lot of right ways to get to Florida. All right, switch gears. I am going to pause this now because you got to switch gears with me.
I was so close.
Sorry, fold your Chromebook halfway shut. Halfway. Oh, yeah, all the way.
I don't. Are we still doing that?
Sorry, I got very distracted. What, Alex?
Yeah.
On A. Hey guys, we don't necessarily have to write a bunch of stuff down here until we get to D, but I do need your attention. A is broken in a sense because we like integers way better than rational numbers. By that I mean we like entire values, right? Whether they're positive or negative, we can deal with that. But decimals and fractions get a little tricky. So we want to fix this. And I forget if we talked yesterday about how to fix A, but there's a pretty quick way to deal with the fact that it starts with half of something, and I don't really want to start with half of something. Mikey?
Multiply that entire side by 2.
Just that side?
Both sides.
Can we only multiply one side? No. So you mean to say
Both sides.
multiply both sides by 2. So Mikey is suggesting if because I can't just do it to one side, do it to both sides, this will become 2 times that. Well, 1x minus, don't fall in the trap door and forget that second multiplication, right? And then this goes to both, so we get equals 2x minus 8. Now we've got all integers. Can we solve this?
Yes.
Yeah, sweet. Talk to your neighbor about how to fix B. How could we fix B? You've got 4 right. We've got 3 right there, 2 right there.
Yeah, we're talking about B.
Miss Olivia, I know that.
Oh yeah, that's right. I forgot about that. I overheard you talking to Nathaniel yesterday.
And then she told me the whole way. I couldn't ask her. She told me.
It's not your fault. Just well, it was probably my fault because I can't talk quietly. It's like
Don't worry,
impossible.
I can't
I
either.
like whisper and people are like, "Do you know that we can hear you?" So okay, fine, Olivia. I heard Mr. Hudson in the thing. Fine, what? Actually, no, never mind. Forget. Liam, we'll come back. You're gonna let the cat out of the bag too soon.
Yeah.
Which is a weird statement, by the way. Liam, any thoughts?
Just multiply by 4.
Ooh, he said the J word. Multiply by 4. Now wait, why? I don't. Why?
So you can get,
Hey.
because if you
Hey.
multiply this, because if you just multiply it by 2, you get the 0.5 to 1, but you would only get the 0.25 to like half.
Yeah, 0.25. What Liam and his team back there probably realized was, 0.25 is really a fourth. So if we multiply everything by 4, that'll fix. And like the other numbers get a little bigger, but what would we rather work with? Big numbers or small numbers? Big numbers.
Big boy.
At least if we're talking about like portion numbers, you'd rather work with bigger numbers. Alright, so I think C is pretty much the same as what we've looked at. Go ahead and talk about D with your neighbors. Go ahead and talk about D with your neighbors. Do D with your friends.
With your friend.
When your teacher makes immature jokes, it kind of pushes like, hey, we could all grow up, right? We could all like kind of elevate our jokes a little bit. So your 323 isn't out is my only concern. You have 3. You weren't here yesterday, right? You guys don't tell me these things. I actually have it ready for you. No, so I got all 3. So we wrote down these special instructions for these homeworks because we're doing like 3 of them in 2 days. So if it just says do, that means do the whole thing. But if it says pick 2, you just pick 2 of them. Like you don't have to do the whole thing. We did B together, so you're picking 2 out of these. And then here it's do A or B, like or do these 2 or do these 2, or you can do all of them if you want. Does that make sense? So then come see me if you have any other questions about that stuff. Alright. Lee's not here. Caden. Well, that's the same group. Well, okay. Caden, do you guys have thoughts about D? Times 20. Now, why times 20? Oh, I don't know. Okay. Oh, so anything bigger than times 10 will work with the 0.6. So you guys chose 20. Oh, because times 10 would be 1.5. So times 20 would be 3. Yeah. No, I made the poop joke. Do D. Yeah. Ah. That shows that we weren't listening. It was probably because you and Anna were talking, which is like what's constantly happening.
I didn't talk to
So,
you at all the entire time.
what if I gave you this?
I was there doing D.
Anna, you're like almost always talking, even when the teacher's talking. Let's just be honest. I trust me, I address it with them as well. But a consistent thing I'm noticing is even when I am like teaching, you guys are just having conversations. Mikey Thompson, how dare you?
I just found out a good way to do this.
Well, Nathaniel already knows, and he brought it to me yesterday, so we're going to let Nathaniel drop this knowledge bomb on all of us. You overheard Nathaniel and I! How is this unfair? How are you mad at me right now? You have no right to be upset with me. Nathaniel, would you like to drop this knowledge bomb on us?
You can multiply by
But what? I don't even see any fractions up here. What do you mean multiply by 100? Why?
Because it has two zeros, it multiplies. It moves a decimal point.
Why am I so stupid?
Hey, get that word out of here.
What? But say it had another number behind the 2 7. You could multiply by 1,000.
Guys,
I totally forgot about that.
you can, he's going to say it, you can just figure out how many decimal places you want to move, and this becomes 14. This becomes 27x. This becomes negative 71x, and this becomes 23.
Oh my gosh.
Wunderbar. So, that's wonderful in German. So, question. In our, because that's as much as I needed to cover today for this, but in our situation, I'm going to unpause Desmos in case you're trying to finish it. In our situation with AV, nerd, whatever, which I'm going to have to pause my video, do you think we have enough data to figure out when the pool will be empty? Talk with your neighbor really quick while I finish pausing my video before I can play this.